Hi, and welcome to Geeks for Geeks. Today, we would be discussing yesterday's problem of the day, that is, longest perfect piece. Now, without any further ado, so give me a quick one if I'm audible as well as equally visible. Just give me a quick one. Okay, seems like I should be. Okay, fair enough. So, this is how I would do it. Yeah. Okay. So let us read the problem statement quickly. So in this problem statement, we are given an array of n numbers. A perfect piece is defined as a subarray such that the difference between the maximum and the minimum value in that range is at most 1. And you need to find the maximum value of that. So what do you mean by this? Summing up. So before summing up and before getting deep into this, let me first explain you what do you mean by subarray. So suppose subarray can be can be thought of a continuous part of a whole body. Like what I want to say is, suppose we have 1, 2, 3, 4. So I can say that this is a subarray, this is a subarray, this is a subarray, this is a subarray, and this is also a subarray. But this and this is not a subarray because it is not contiguous. Okay, fair enough. So let us go back. Okay, so now in this problem, we are told to find a subarray such that in that subarray there would be a maximum value and minimum value. And the difference of that is at most 1. What do you mean by at most? At most means ज़्यादा से ज़्यादा 1. Okay, like we can have the value as 0 or 1 because difference, okay, we know between the maximum and the minimum, the difference can never be negative. So either can be difference can be 0 or either the difference can be 1. Okay, so please see to this. Now let us move to this. Okay, so we need to find the maximum value. So if we were to find the minimum value, then the minimum value would be just 1 because in a single element the maximum value would be that and the minimum value would be that, and the difference between them is equals to 0. So give me a quick one if this thing is clear. Give me a quick one. Okay, so hi, Yash. Okay, so now let us see the given sample test case. In this given sample test case, we stand here and we see the subarray, and we can see that this is the largest possible subarray, and the value is 4, which is the number of elements in that particular whole array. So we can say that the value to this is equal to 4. Now let us move forward and see the next sample test case. The next sample test case. Okay, so in the sample test case, we stand here at the longest subarray is 6. Okay, so 6 is the minimum value, so that means this, and the maximum value is equal to the longest subarray is from 6 to 10. Okay, so 0 1 2 3 4 5 6 6 7. Yeah, this one. 1 2 3 4. No, 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 this one. Okay, this one would be the longest subarray. Okay, why? Because the maximum element in this is equal to 8 and the minimum element in this is equal to 7. Okay, so now the very first approach is that we find all subarrays. We find all subarrays. Then we find the minimum and maximum. Then we find the difference. Okay, that is maximum minus minimum. And if this is less than equal to 1, at most 1, less than equal to 1, okay, at most 1 less than equal to 1, then we can say that this is a correct value. And if the particular subarray has this property, then we would compare to the answer. Compare the answer itself. Okay. So now the next thing is finding the minimum and maximum value can be done by simply traversing over it and taking a minimum value, taking a maximum value and then taking the minimum value. So it would be done. Finding maximum and minimum in an array can be done. But how to find all possible subarrays? Find all possible subarrays can be done very easily. How? Let me just show you. Suppose we have 1, 2, 3, 4. So what we can do is we can keep a pointer here and a pointer here. So now in the first one, we can see that the element, the range from that pointer to up pointer to down pointer would be our subarray. This. Next, we would move this pointer in front, and this time the subarray would be 1, 2. Then we would again move this pointer forward, and the subarray would be 1, 2, 3, and then we would again move this pointer and we would see that we would have 1, 2, 3, 4. If after the first pointer has successfully iterated till the end, we would again have a pointer here and we would again have a pointer here. Okay, so as you can see, both the pointers start from the same point. Okay, so now we would have the values as 2, then this up to down, that is 2, 3. See how cleverly we are doing it. Okay, then we have the next one, that is 2, 3, 4. Okay, now we have the next one here and the next one here. So now we have this as 3, and next we have 3 and 4. Okay, in the next iteration this would move forward and they both would start from the same point. So now as you can see, we have found out all the possible subarrays that can be taken into consideration. So after finding out all possible subarrays, what we can do is, after finding all possible subarrays, what we can do is we can just find the minimum and maximum. If minimum minus maximum minus minimum is less than equal to 1, we would compare the length to the answer variable, which would be initialized with 0, because the minimum value is 1 or 0. So simply assign it with 0, 1 would also solve the purpose. So am I clear with the brute force approach or not? Talking about what would be the time complexity of this approach. So at each point, we are pointing to one element and we are iterating over all the others. So for one point, we are doing n iterations. Okay. So we are pointing at one element. We are pointing at one element, and in return we are doing n iterations. Okay, so if we point to n elements, then this would be n square iteration. So the time complexity to find all possible subarrays is n square, and the time complexity to find the maximum minus minimum is constant, of course, and comparison and maximum is also constant. Time complexity is n square and the space complexity is 0, because we are using just variables, no auxiliary data structure. So now can I have a quick yes if the brute force solution is clear? Can you please explain this question? Okay. What is this? This is the weirdest question I have ever seen. To be honest, this is the classical question of, I would reveal you after I've explained the question. Okay, this is not the weirdest question. This is a classical question. It can't be categorized as easy, I agree, but this question is not weird. This is a classical question. Can you please explain the code once question once again? I have already explained it. Okay, fair enough. At this point, everyone is able to understand. Now let us go back. Okay, so now let us see what do we need. Okay, so let us copy this one. Okay, we have this. So now what we can do is we can kind of use a two pointer in this. Okay, how two pointers? I would tell you that. So let us first understand what is two pointers. Okay, let us first understand the concept so that when we would come back to this example, we can say that we already know two pointers. Okay, so two pointers application. There are many applications of two pointers like palindrome checking and all, which are very easy application. But variable sliding window is a major application of two pointers. Whenever you can see that this is a sliding window kind of thing. How sliding window kind of thing? I would tell you that. Suppose we have 5 and 4 and we know that maximum is equals to 5 and minimum is equals to 4. So can we slide the window? Yes, we can slide the window to 4 and 5 again, then 4 and 5 and 5. And similarly, we would just update the maximum and the minimum. But the query is that window of size 2 is not our answer, window of size 3 can't be our answer. So we never really know at which size of window it is possible as an answer. This is our main concern. So now we can say that we kind of have a conclusion that this is a variable window kind of thing. Variable window kind of thing. Okay. Now what more do we have? What more do we have? So if you observe, every time we have we need the minimum and the maximum. This is the very first thing. This is the very first conclusion we can think of. Okay, variable window, and we want the minimum and the maximum value. Okay, let us move forward to the next. Okay, so now what we can do is, suppose we know that we can have something like this and something like this, and we know this from this point to this point, this point to this point, we have a correct solution. That for minimum value is 4 and maximum value is 5. We know this. Okay, so let us take the indices also. 0, 1, 2, 3, 4, 5, 6. Okay, so now we can say that this is equal to L and this is equal to R. Okay, now suppose we already know that we have the minimum as 4 and we have the maximum as 5. But as we move forward, okay, as we move forward, we can see, okay, let me just remove the indexing. Okay, yeah. As we move forward, we can see that 5 is now lost. When 5 is lost, we can't really find the minimum and maximum again. So yes, maximum can be there. So basically we need to trace back. Okay, like what was the second maximum? Because suppose it might be a scenario, मतलब एक scenario लो जहाँ we have 5, 7. Okay, let's not have, yeah. Suppose we have 6, 5, 4, and we know that the maximum value is equal to 7. Okay, the maximum value is equal to 7. So now when we would decrease this pointer, that is we make this pointer go here and we remove this 7, then we need to iterate on the whole array one again, so that now we need to find the find again the maximum value. So to find the maximum and the minimum value in a variable window kind of thing, whenever that element goes off, we need to again iterate and find the minimum or the maximum value again. Do I make sense? जैसे हमारे पास 7 4 5 है. Okay, then we have something like this. Suppose we know that, or let's take a very 3 2 1 and then 5. Yeah, suppose we have this. We know कि start से लेके end तक का maximum 7 है. Okay, now suppose we decrease this pointer, and we want to know the maximum from here to here, maximum from 4 3 2 1 5. So now we need to again iterate and check which is the maximum number. So we need to think of a way so that the next maximum can be easily brought up whenever we remove the first element. डू आई मेक सेंस? मतलब जो 7 चला गया उसके बाद हमें 5 चाहिए, 4 नहीं चाहिए. सो बेसिकली अगर 7 हटने के बाद हमें क्या चाहिए, सो वो हमारा कंसर्न है. सो वी नीड टू हैव अ वे so that we can trace back the maximum and the minimum value. How can we do this? Okay, fair enough. Hi, your voice is so soothing. I will kill for a voice like this. No, my voice is absolutely very deep. Okay, it's not soothing to be honest. Okay, okay. So now, whenever you have a condition like this, okay, whenever we have a condition like this, then you should think of that we can store elements. So the reply to this is, to solve this issue, what we can do is we can store elements in a sorted form. And the next requirement is that we should be able to delete elements. We should be able to delete elements. So whenever we have dynamic elements and we want sorted form, and deletion and insertion is there, so जब भी deletion insertion रहे और sorted form की need रहे, then only two kind of data structure should pop in your head. The very first one is priority queue. Next one is set. If you have unique elements, if you don't have unique elements, if you want to store duplicates, then you need to think of multi-set. Either of them is fine, and even map is also fine. Hash set, okay, like hash set and priority queue, unique elements के लिए set, duplicates element के लिए multi set. Okay, so we can do this or not. So now by doing this we would be able to trace back the value. How can we trace back the value? Let me just show you. Okay, so now see how easily can we trace this value. Okay, so we have here one and this. So now we have it in a, suppose, simple hash map, okay, where everything is sorted. So we have in the sorted form 1 2 3 4 5 and 7. Okay, so now if you remove this 7 to 4, then you don't really need to iterate on the whole array once. Just remove this number from the multi-set or set. Okay, because this is a unique number, basically duplicates can be there, so think of multi-set only. Okay, what is multi-set? Same kind of priority queue. Okay, why are we not using priority queue? Because we don't really need just the maximum element or the minimum element, we need both of them. And multi-set, okay, set stores unique values, and multi-set stores duplicate values. So multi-set allows us a way of accessing both the first element as well as the last element. But in priority queue, we can only take hold of the very top element. Okay. So, okay. So now what we can do is we can simply take hold of the first value. It would give the minimum. We would simply take the last value. We would get the maximum. Very simple way. Now we can see that we can have a variable sliding window, and a variable sliding window is nothing but a two pointer. Okay, so give me a quick one. I won't be minimizing this, but now I would be telling you the final approach to solve this problem. Okay, so now see how would we solve this problem. Okay, so very first is that we would have 5. Okay, let's take a different color. We have 5 and then we have 5. So we know that the multiset would consider 4, 5, 5, 5. Okay, and in here the size of the multiset is 4. So we know that up till now we have an answer of 4. First, we would simply increase the value till this range is till the difference between maximum and minimum is less than equal to 1. Okay, so done till this point. Next, what we would do is we would increase this pointer. If we increase this pointer, okay, if we increase this pointer, then that means that we need to remove 1 5. So we would remove 1 5. Then now still the value is less than equal to 1. Yes, it is. Okay, so now we would simply move forward. Okay, so now we would simply move forward to this. Okay, and then we would iterate accordingly. So now what, the value is greater than 1, if the value is greater than 1, if the difference is greater than 1, we would keep popping out elements, okay, till the difference from the maximum and minimum is less than equal to 1. Okay, so while this condition is true, we would pop out elements, and while this condition is true, we would compare and save, compare and save, and increase the pointer, and we would simply increase the pointer. Okay, here if the difference is large, so we would simply remove elements till the value is less than equal to 1. If the value is less than equal to 1, we would compare and save. This would be the very first proceeding that needs to be done, and then we would increase the pointers. Okay, so now give me a quick one before we move to the implementation of this one. And this is a very easy implementation, to be honest. Okay, fair enough. At each and every window, we need to find the okay. Hi, Anamita Sarkar. At each and every window, we need to find the maximum and the minimum. Yes, sliding window of variable slice is nothing but two pointers. In set, elements are present in sorted order, but we the duplicacy is not allowed. Like if you push 2 5 in the set, only 1 5 would be stored because it stores only unique element. Okay, because it does not maintain order. A hash map or a hash set won't work. No, it's not. If you use map, it stores element in a sorted form. If you use unordered map, then this won't work. Okay, ordered map, yes. In Python, the elements are not present in a sorted order. What kind of data structure we use in Python? So data structure which can be used in Python might be the dictionary only. I think so. I think so. I'm not sure absolutely. But map would not allow duplicates unless you map. Yes, absolutely. Map also won't see key value pairs can't be duplicate. You can't replicate a same key only. So you just store its frequency. Obviously, this is very much understood. Okay, fair enough. So let us move forward to the implementation. Okay. Okay, so I need to stop the camera. Why do I have something like this? Mm. Okay, just let me see. Okay, okay, it's looking good then. Mhm. Okay, let's code like this only. Okay, so I'm more accustomed to A, as you all know, and lowercase values, so I would do that. Next, we would initialize the answer to equal to 1. Why? Because a single element, the difference between a single element's max and min would be 0. So the worst answer can be 1. Or to be on the safer side, you can just initialize the answer to 1 also, okay, 0 also, whatever it be the condition, but we would initialize it with 1 itself. Okay, next we move forward, we would have a left pointed 0 and a right pointed 0. Okay, so left L is equals to left and right, so first they would start from the same position. Okay, so now we have the left and right, so left and right. So if the right pointer, okay, if the right pointer is less than n, then the, so I would just show you this, what do I want to convey you. Okay, so I want to say is that suppose this value is equal to n, and here we have a left value and here we have a right value. So this segment is valid if right is less than n. So basically we don't need to check for L. Why? Because the implementation would be such that L would never cross R. So if we just check that R is less than n, it would make sense. So that is why only having R less than n would solve the purpose. We can have L is less than n also, but that is not required. Why that is not required, I have also shown you. Okay. So first what we would do is we would insert. So I have not initialized multi-set. So multi-set MS. Okay. So multi-set, the default multi-set. Okay, stores element in the sorted manner. That is, the very first element is the minimum element and the last element is the maximum element. Okay, so first we would insert one element. Why are we inserting elements in the very front? Because if the multi-set is a blank, then we would be trying to access some element and that is not present and we would have an error. That is why we are prioritizing on inserting an element first. This is very important. Okay, so we would insert a of L. Okay, and then we need to do L plus plus, but we can do it at this point also. First L would be used and then it would be plus plus. Okay, this just means that L and then L plus plus, the same thing, post increment operator. Okay, so now we would say that the value on ms dot r begin. Okay, what do you mean by r begin? First I would write and then I would show you what this is happening. R begin, the value, subtract the value of ms dot begin. Okay, if after doing all this it is greater than 1, if it is greater than 1 we would shrink the size. Okay, so we would shrink the size. Okay, we would shrink the size from this side, but the thing is that we would need to remove that element from the multi-set also, so that the maximum and the minimum is updated accordingly. So we would say ms dot erase, ms dot find a of r, and that should be good to go. We can do r and then plus plus, but we are just doing in a same. Okay, so what we would do is, if it is greater than 1, we would keep moving forward and we would keep removing the r value. Okay, and that should be done. And then we would have answer is equals to max of answer, and then int, okay, ms dot size. Okay, we are converting the size into int and then we are comparing it, and at the end we would just return the value of the answer. And this is this much easy. Okay, so first, so this can be, okay, this needs to be r and this needs to be l. Yeah. So basically first we are adding the elements from the right hand side. First we are increasing on the right hand side, and when we are erasing from the left hand side. That would be done. Okay, we just compile and see how many errors are we making. Okay, fair enough. So we were able to solve the problem. Now let us talk about the time complexity also. Okay. So let me just explain you what this is all about first. So suppose we have one, two, three element in the multiset. So the address of this can be accessed by the iterator of begin. And in the same manner, if you just add r begin, that is reverse begin, this would point to the last element. And similarly, you can also do one more thing, end, which would point to the element after the last element, and you can just subtract 1 from it. And it would also solve the purpose, end minus 1 or r begin. R begin would be same. So R begin is more simpler and easy to use. So that is why. So R begin would have the maximum and this would have the minimum. If the difference of them is greater than 1, then we are removing elements from the left hand side. First we are removing elements and then we are increasing the value of L. Remove L and then L plus plus. Remove L and then L plus 1. Remove L and then L plus 1. After this thing is after this thing is over, then the difference would be less than equal to 1. So it would come here and it would compare the size to the answer variable and it would store the maximum. At the end, the answer is there. Okay. So let us talk about time complexity also. Talking about the time complexity. So we are using a multiset here. So multiset, each operation can be thought of as log n. So we are inserting n elements in total and n iterations are being done. Okay, so n elements are inserted and l elements are taken out in the worst scenario. So we can say that for one element an operation of log n is required. So for n elements an operation of n log n is required. Now, what is the space complexity? The space complexity is big O of n. Why? Because we are using an auxiliary data structure that is multiset, and in the worst scenario, every element of the array is stored in the multiset. Okay, but we are not deleting any element again and again, and we are not inserting any element again and again into the multiset multiple number of times. Okay, fair enough. Do I make sense? मतलब लेट्स सम अप लास्ट थिंग इन हिंदी. मतलब अगर टाइम कॉम्प्लेक्सिटी समझा जाए ना, तो एक एलिमेंट को सिर्फ एक ही बार इंसर्ट कर रहे हैं और एक ही बार निकाल रहे हैं. ओके, दैट इज बिग ओ ऑफ 2n इग्नोरिंग द कांस्टेंट, दैट इज बिग ओ ऑफ n. एंड स्पेस कॉम्प्लेक्सिटी भी वैसे ही होगा. एक एलिमेंट को हम लोग सिर्फ एक ही बार मल्टीसेट में पुश कर रहे हैं, एक एलिमेंट को हम लोग बार बार नहीं कर रहे हैं. दैट इज व्हाई टाइम कॉम्प्लेक्सिटी इज बिग ओ ऑफ n. ओके, so any questions? Sir, is it possible in big O of n time and constant space? It can be possible, but it depends on the choosing of data structure. So if you just do the data structure, like you can write your own hash function and all, and it can be done, to be honest. Why? Because the elements are till 10 to the power 5. So you can have a hashing kind of thing. Okay. So you can, yes, I have heard it. Okay, Priyavrata, I was explaining, and the flow of the explanation should not be broken down. Any further queries that you have, I would wait for the next 30 seconds and then I would turn off the session. Okay, seems like everything has been covered. So if you can design your own hash function, this can be done in even big O of n. Okay, so I see no more doubts coming in. So that was it for today. If you are watching this stream after the live stream, consider liking the video and commenting on the video so that the reach of this video could be increased and this work could be justified. Hello, Naikaj, how are you? Okay, so that was it for today. Good night, everyone.